Hello, and welcome to GP Podcast.
You know, at CES 2026, something fundamental shifted. The whole abstract concept of artificial intelligence, all that code living up in the cloud, it came down to earth. It grew limbs, it got wheels, it learned to see the world not through a screen, but through its own eyes. This is the story of the day AI got a body.
For years, right, we've talked about AI as this disembodied brain. But what happens when that intelligence is no longer just a voice on your phone or some text on a screen? What happens when it can actually walk into a room, perform a task, or drive you across town? The future we imagined isn't sitting on some distant server anymore. It's here, and it's physical.
So, how did this massive shift actually unfold? Well, we're going to break it down into 5 key parts. We'll start with the most visible change, the humanoid wave. Then, we'll look at intelligence on the move in other forms, explore the new ways we interact with tech, witness the autonomous revolution in our cars, and finally, we'll try to understand the connected future that ties this whole thing together.
First up, the trend that was impossible to ignore, the absolute explosion of humanoid robots. And I'm not talking about one company with some flashy prototype. No, this was a clear signal from the entire industry that the era of physical, general-purpose AI, it's beginning right now.
And what's really interesting is that everyone's tackling this differently. You've got companies like Neurobotics, and they're all about refinement, making their humanoids' movement super smooth and controlled so it can work safely right alongside us. But then you have Fourier Intelligence designing its robots for healthcare with these intentionally slower, more predictable movements. Why? To guarantee patient safety.
But here's the common thread, the secret sauce connecting a lot of these different approaches, the shared intelligence stack. Now, think of it like this. It's one brain from many different bodies. A skill learned by a giant industrial robot can be instantly transferred to a smaller one in a completely different field. This is a huge leap for efficiency, and it speeds up development like you wouldn't believe. Which brings us to Agibot. They took a totally different approach, pure scale. They didn't just show up with one robot, they brought the whole family, from full-size general-purpose bots to compact social ones, and even a 4-legged inspection unit. They're basically signaling a move from just tech demos to real market readiness. Their ambition is to have a robot for pretty much any need you can think of.
But AI isn't just taking on a human shape. It's also being built right into the heavy-duty machinery that runs our world, taking on some of the toughest, most complex jobs on the entire planet.
Caterpillar actually called their new system a digital nervous system. Now, this isn't AI in the cloud, it's intelligence running directly on the construction equipment itself, on device. And why is that so important? Well, because remote job sites don't have reliable internet. The machines have to think for themselves, sharing data with each other about terrain and workflow all in real time. And then you've got Oshkosh, applying that same on-the-ground intelligence to one of the most stressful places you can imagine, the airport tarmac. They've developed these autonomous robots to manage aircraft turnaround, that supercritical window between landing and takeoff. They guide planes, manage ground tasks, and just keep things moving, even in terrible weather. And the goal is simple: fewer delays and safer operations for everyone. You know, sometimes innovation is just about solving one specific nagging problem. And that's exactly what Sendigen's Rover X3 is. It's a rugged little inspection bot whose superpower is climbing stairs. It sounds simple, but that's a huge obstacle for most indoor robots. This one ability opens up entire multi-level buildings to automated monitoring. It's a small but absolutely crucial piece of the physical AI puzzle.
Okay, so let's bring the focus back to us for a minute. With AI now moving around in the physical world, how we actually interact with it is changing too. And the big theme here is a huge move away from the screen as our main way of doing things.
So, take the Reno X3 Pro smart glasses. They're not really AR glasses. A better way to describe them is a wearable AI terminal. And here's the key difference. They are completely standalone, no phone required. They're designed to give you quick, contextual info, like a notification or navigation, without blocking your view of the world. It's all about assistance, not immersion.
And this whole idea of practical, less intrusive tech, it was everywhere. It felt like a shift away from just cramming in more screens and features, and a return to creating tech that serves a direct purpose. We saw it with the Lunaband, a health tracker with no screen, and the Clix communicator, a phone that brought back the physical keyboard. It's all about making tools that solve real-world problems, not create more digital distractions.
So all of these different threads, the physical bodies, the on-device intelligence, the new interfaces, they all converge in one place, the automobile. The car is on its way to becoming the ultimate and probably the most complex consumer robot.
And at CES, we saw two radically different ways of getting to that future. On one side, you have Ford, taking an evolutionary approach. They're integrating a sophisticated AI assistant and advanced driver assist features into their next-gen EV platform. And then, you have Tensor, taking a revolutionary path, building a vehicle from the ground up, all centered around a powerful AI brain.
Over 8,000 trillion operations per second. Just let that number sink in for a moment. That's the raw processing power inside Tensor's Level 4 autonomous RoboCar. It's basically a supercomputer on wheels, powered by 8 NVIDIA Blackwell GPUs, and it's designed to handle the insane complexity of city driving all by itself.
And this isn't science fiction. Look at these timelines. Tensor is planning to start delivering its robocars in late 2026 and launch in its first markets in 2027. Meanwhile, Ford is targeting eyes-off driving capabilities for 2028. The race to a fully autonomous future is on, and it is moving incredibly fast.
Of course, none of this just happens in a vacuum. This whole revolution is powered by an entire ecosystem of hardware, from the new AI-powered laptops from Dell and Samsung to the super powerful components inside these new machines. Every single piece of our digital world is getting faster, smarter, and more connected to support this new era of physical AI. So, as we walk away from CES 2026, the big question isn't just about what this technology can do. It's about what it means for us. As our own creations become more capable and more physical, walking and working right among us, we're kind of forced to reconsider our own role in all of this. As intelligence becomes physical, what does it truly mean to be human?
If you liked the video, subscribe, leave a like, comment on what you liked most, and share the video.